Hey everyone, welcome back to my channel. This is Lakshya here. So today we're gonna start with our lead code question number 1922, which says count good numbers, and it's a medium level question in a lead code. So let's see what it says. It says a digit string is good if the digits 0 indexed at even indices are even and the digits at odd indices are prime, like 2, 3, 5, or 7. Let's for example 2582. Here indices are 0, 1, 2, and 3. So this string is good because the digits 2 and 8 at even positions are even. So we can see that 2 and 8 are at even positions and they are also even, and the digits 5 and 2 are at odd positions and they are prime. So what we infer from it? We infer that the even indices, the even indices, the even index should have always even numbers only, and the odd indices should have always prime numbers. Okay, that's why then only a string will call a good number. Okay, so that's it. So what we have to do in question: given an integer n, return the total number of good string digit strings of length n. Since the answer may be large, return it modulo. Okay, a digit string is a string consisting of digits 0 through 9 that may contain leading zeros. So in this question what we have to do, we will be given a n, means the size of a string. For example, here n equals to 0 and output equals to 5, like this. Here n equals to 1 and output equals to 5. And how so? N equals to 1 means a string should only be length of 1. So the all the strings that can be length of 1 will be 0, 1, 2. So but we have to keep in mind also one thing, that here n equals to 1 means only one index will be there, and that will be 0 index. So we know that 0 is an even index, so it have the condition that only even number should be there, so we can't use this. So there will be 0, 2, 4, 6, and 8. So we can see total how many are there: 1, 2, 3, 4, 5. That's why our output is 5. Similarly, for n equals to 4, our output is 400. Okay, so how can we approach this problem? Let's understand it more deeply with the help of another example. Let's take example equals to 6, n equals to 6. Okay, that means we are having a string of length 6, like this: 3, 4, 6, and the indices will be 0, 1, 2, 3, 4, 5. Now we know that at even indices there will be only even numbers, and at odd indices there will be only prime numbers. So we know how many possible cases will be there. Like for 0 index, we know that 0, 2, 4, 6, 8. These are the possibility. And for this odd index, what are the possibility? 2, 3, 5, and 7. These are the only prime numbers that exist between 0 to 9. And for this, it's same like this. For this, it is also same. And for this, it is like this. And for this, it is this. Okay, so we know now these are the possibilities. Now let's write down. So you can see that this is 5, but this total 5 possibilities, and how many times? For this, for this, and for this, means we are having 5 to the power 3. We can write it like this also, like 5 possibility for this, and we are having 4 possibility for this, then 5 for this, then 4, then 5, and 4. So we can write it as like 5 to the power 3 and 4 to the power 3. And after calculating this, what we will get? 5 5 25 to 625, it means it will whatever it will be our answer, that will be our output. You can calculate it yourself. For example, n equals to 4. Let's take this example only. We have 4 indices, that will be 0, 1, 2, 3, and each will have 5 possibility for the even indices and will 4 for the odd indices. So we know here are 2, that means 5 to the power 2, and here are 2 odd also, that means 4 to the power 2. So it will be 5 5 25 into 4 4 the 16, which will be our 400, and that's our only answer here. So how we can find this? we have to nothing do. We will just have to return this function that will be power of 5, because 5 is for even. And how to find the even number of indices? It will be always n plus 1 upon 2. This will returns the even number of indices, and this will return the odd number. This will return the value of the power of odd, like 4 into n by 2. N by 2 represents odd indices number of, and it represents even number of indices. Okay, and we have to simply return this function. Okay, cool. Now what we do in this function, let's discuss. Okay, what we perform in this function. So this function says that a number have only two possibilities. Okay, for example, a is having a power of 12, so it can be divided into a to the power 6 into a to the power 6. And if a number is means if a number is even, it is distributed like this, and if the number is odd, like a to the power 13, it will be distributed like a to the power 6, a to the power 6 into a. So what we can infer from it, we can say that if a to the power b, if b is even, okay, then we will return a to the power b whole square, b to the power 2, sorry. And if it's odd, if b is odd, then we will return a into a to the power b by 2 whole square. Okay, because we need an extra a, like this. We are having 13, we can write it as a to the power 6 into a to the power 6, but we need another one because it satisfies only 12, but we need 13. That's why we also uses once again a. Okay, and the number we will got, let's store it on, let's say it as half. So we will get half as like this, and then we will store it and the result. Okay, result will be our half into half. So our half will be like this. It will return us the value of half of our original value, and then we will store it in result like this, half into half. But before that, and also we will also check if our b means our power percentage 2 equals to 1, which means odd. So then what we will do, we have discussed that we will add another also, means another value also. The value of a means one another a, that means result equals to result into a. And on each condition we have to also keep in mind that we have to return the value modulo 10 to the power 9 plus 1, means value should not exceed this value. So we have to always use modulo for the long values, like the values that are in lakhs or crores. It will help us to decrease that value and give us a value inside this range. Okay, so let's write the pseudocode for this, then you will understand it more clearly. Okay, so first of all, our only code, our main function is this, where we have to directly return our power of, for even we know total 5 cases are there, and to find the number of even indices, we will use this, and it will be multiplied by power of 4. So they are the number of possibilities for the odd indices, and here it will test us number of odd indices, like this is going to return our answer. Now we will create our power function. Okay, so how to create our power function? So our power function, we will pass first of all as a as b, like this. Okay, let assume it is as a, insert the number like this, a to the power b. Okay, and b as the power. Okay, so now what we have to do, first of all we will check if b equals to 0, it means now power equals to 0, simply return our 1. If not, so what we'll have to do, now what we will do, we will find the half, like we discussed, half with the same function, that is find power, or you can say power, we have used power here, so we can say power, and we will pass the number but with half the power. We will pass the half value, then what we will do, it will return us the half of this. Okay, so now what we will do, we will add result equals to half into half, like this. It's easy. Then what we do, We will also check if b percentage 2 equals to 1. Means if our b was odd, means our power is odd, which means we have to add another one extra a in the result to get our desired result. So we will do the same like this. At the end we will return our result. Cool. But in the whole process we have to also keep in mind the modulo thing that we discussed earlier. So we will always perform like this. We also use m here to calculate the this, so that our value not exceed the value, and also here also, so that its value remain under this range. And at the end also perform like this here also. Okay, fine. So how the recursion is basically working here, you can see that we are again calling in power. So it's basically like this, like we are having 2 to the power 12, so it's now calling for 2 to the power 6, now 2 to the power 3. So like this is it's going till the power becomes 2 to the power 0, then it returns, and at the end we get our answer. Okay, so it's kind of reverse of exponential, where we are having the output, because we know that the output is fixed, it only have 5 number of test cases. So we are trying to find that what are the possibilities, total number of possibilities. That's it. So that's it, this is your pseudocode. This is how you approach this problem. It's simple, you must try this code yourself. Let's jump to the final code. So here is a code where we have first declared our modulos, that we have to perform modulos our limit, that is 10 to the power 9 plus 7. Okay, so we have to create it as a global variable like this. Now here is our main function. And why we have used long, we have used the variable, means the data type long, because a value can be very much long. That's why it can't be stored in as int double. That's why we have used long, so that it does not cause us any error, compilation error. So okay, that's same. We have written long, find power. It's the same function that we discussed earlier. Then we have used our function here in power. It calls it here. First our base case, it checks. Then we have calculated our half. Then result becomes half into half, or then modulo m, so that it stay in its limits. Then again we have checked if the power was odd, we have multiplied one more extra, and at the end we have written our result. So now what's the time complexity for all this process? So the time complexity was big O of log n, because the exponentiation takes log n time, and we are dealing with two we are doing exponentiation two times, means big of log n plus big of log n. So at the end it becomes, because it's for one time for even and once for odd, that's why it results in total of time complexity of big of log n. And what's our space complexity? Our space complexity is big of 1. Also, because we are not using any external space like stack, queue, something like this, we are not using anything, we are just using our simple variables. So that's it, this is all your code and your explanation. So thanks for watching, see you later, bye bye.